So on this first part of lesson 7.7, we're going to focus on the steps for factoring trinomials like we did yesterday, except these trinomials are going to have a leading coefficient that is not just 1. So everything you did with the magic numbers in the last day or two was a nice, setup of finding those two factors that add up to the middle number. And we really only had to worry about the second set of numbers because the first leading term had an a value or a leading coefficient of just 1. So we just always knew that the first two numbers, if the first term is x squared, it had to be an x and an x. We didn't have to worry too much about the first part of those binomials. When you have a number other than 1 in the leading coefficient, that really changes up the game, okay? Because it really kind of expands the different possibilities of factors that you could have. So we have a different process for how to tackle that. And in order for me to teach you that for those trinomials, I'm first going to teach you how to factor by grouping, which is another skill you need to know anyway. So when you factor by grouping, or factoring by grouping, wow, I really underestimated how much space we needed for that, right? So factoring by grouping is helpful to factor polynomials that have 4 or more terms and don't have a GCF. So we're going to get to the trinomials in just a moment, but first we're going to talk about 4-term polynomials, right? So if we have a polynomial with 4 or more terms and they don't have a GCF, we always look for that first, then the next step is to attempt this particular process called factoring by grouping. And you have a nice example of how you go about that. But basically, you're going to take those 4 terms and you're going to break them up into kind of 2 groups, right? You're going to group up the first 2 terms together and you're going to group the second 2 terms together. And then you're going to play the GCF game with that. So if there's no GCF among all 4, then fine, no problem. We'll kind of group these into these smaller little sets of 2s, and we'll look for a GCF just within that group of 2. So you can see that happening kind of right in here. We group the first 2 terms, and then we look to see if there was a GCF just in that term, just in that group, sorry. And we realize, oh yeah, 2x squared plus 8x, 2 goes into both of those, and x goes into both of those. And so we factor that GCF just from that tiny little group, and we rewrite it like we had been with that GCF written out in front. So now we have the 2x in front of the parentheses, and the leftover factors are x plus 4. Then you do the same thing with the second little group that you made of the 2 other terms. So we look at that 3x and the 12. We notice, is there a GCF? Why, yes, 3 goes into 3x and 3 goes into 12. So we factor it out in front, and we write those leftover factors in the parentheses. And then something pretty magical happens, because if you didn't know, math is like practically magic, right? Check out what we have left. We now have essentially this product right here plus that product right there. Now pay attention, because if you pay attention on this, the rest of it gets easier. Here's what's happening. I have that product plus, so I have the 2x times x plus 4, that product right there, plus 3 times that x plus 4. Well, even though it's a little bit bigger, x plus 4 happens to be a common GCF in those 2 terms. So kind of like in the step previous when we noticed, oh, a 3 goes into 3x and into 12, and we realized there was a GCF of 3, okay? Notice that there's this GCF of x plus 4 that is present in the first term, and right here, right? And there's that x plus 4 factor also present in the second. So you're going to pull out that x plus 4 just like you did the previous GCFs over the last few days, just like we pulled the 3 or the 2x. We're going to pull the x plus 4 and say, hey, these guys have an x plus 4 in common that we can also pull out like a GCF. And so your final answers here end up being the x plus 4 that was a common factor, and then just like in before, in the other parentheses, those leftover factors that are left behind when you factor the GCF. And voila. all of a sudden, that very kind of intimidating looking 4-term polynomial has been factored into 2x plus 3. That's one of your factors. And x plus 4 being your other factor. And like I've said over the last several lessons, you could always FOIL that together, or box method, whatever method you love, but you could multiply those two back in, and you would realize you would indeed end up with 2x squared, a plus 8x, a plus 3x, and a plus 12. Okay, so that's called factoring by grouping. Let's practice it a few times here so you can see it in action. So first things first, we look for a GCF. I promised y'all that would be the case before, and sure enough, here we are. Okay, so always look to see if there is a common factor across all your terms that you could factor out before you even, before you even begin, right? But I'm looking at 12, 21, 28, 49. Those guys don't have anything in common. And the p's also, even though I have p squared and then a p term and another p term, the 49 doesn't have a p variable to give me. So I don't have anything that all four of these have in common that I could pull as a GCF. But I'll always check for that first. So then step 2 then is, since I have 1, 2, 3, 4 terms, this is going to be the method anytime we have 4 terms, is I'm going to group the first 2, and I'm going to group the second 2, and then I'm going to do kind of a smaller GCF check just for those groups, right? So just within the first 2 terms. Is there a GCF there? Is there something that goes into 12 and into 21? The answer is yes, right? We might recognize, oh yeah, 3 goes into both of those. And also, is there a variable GCF? And there is, right? So remember, lowest power becomes your greatest common factor. So there's one p there, so I can factor out a p. All right, so just within this first little group, I'm going to pull a GCF of 3p. And when I divide those terms by 3p, I should end up with a 4p here, because 12 divided by 3 is 4, and p squared divided by p is p. And then in the second term, negative 21 divided by 3 is a negative 7. And the p being divided out, then that's done. Okay? So that's me factoring a GCF just for the first 2 terms. Okay? All right. Let's try the next one. So in the next group, is there a GCF between 28p minus 49? So we think about it for a little bit, and then hopefully we all draw the conclusion that yes, 7 goes into both of those. 28 is divisible by 7, and 49 is divisible by 7. There's not a variable GCF, because 49 doesn't have one, but I can definitely factor out a 7, and when I divide by 7, oh, look, here comes a magic trick. Don't miss it, right? 28 divided by p happens to be, a 4p, and negative 49 divided by 7 is, oh, wow, a negative 7. And all of a sudden, we realize that we have now 2 matching binomial GCFs, right? So now that I've done the little grouping and I've pulled those GCFs, now I realize that this first product has a 4p minus 7 factor, and then I'm adding the next part, right? And then after the addition sign, I have another product that contains a 4p minus 7. If I did this correctly, and this is factorable, that's the gorgeous, beauty, magical moment of this, is that you end up with matching binomials. And that becomes essentially a common factor, right? And now I'm like, oh, wait a minute. Both of these contain this 4p minus 7 binomial that I can now also pull out to the front. Just like we had pulled out the 3p or the 7, we can pull that out to the front and write it at the front of the parentheses like we've been doing with GCFs. And then in the other parentheses, I can just write what's left over when I factor that out. So if I factor that out in the first term, that just leaves me with that 3p. And in the second term, it just leaves me with the 7. Guys, and we just factored a 4-term polynomial. Mic drop, right? So check it out. You can always follow that to check it. But things you want to be on the lookout for is make sure that within each of those, there's nothing else that could be further factored. So look at 4p minus 7 and just confirm, yep, those guys don't have anything else in common. There's nothing else that I left behind. They don't, 4p minus 7, there's nothing else I can factor out there. And then check the 3p plus 7 and make sure that has nothing that they have in common that can be factored out. Okay? And if you're good to go, then those are your factors. And you can always check it by foiling, and just making sure it still produces those original 4 terms. Let's try number 2. Let's do it one more time. I'm going to let y'all practice one on your own. Okay, so on number 2, I look for a GCF all the way across the board. but pretty quickly I could tell there is not one. 7 is prime, 5 is prime. There's not k's in every term, so we're good there. So let's group the first two. Let's group the second two. I'm going to go a little faster. I'm going to look for a GCF in the first term. In the first group. Sorry. So 7k squared plus 28k. I want to notice that they have a 7 and 1k factor in common. So I'm going to factor that out. And in the parentheses, I'm going to leave behind the leftover factors after I've divided that out. So that leaves me with just a k in my first term and just a 4. So hopefully at this point, since we've done this a few days now, you're really comfortable in how I got that. Okay, so I'm going to start going a little faster through that process. In the second group, 5k plus 20. I'm going to look at that, figure out, oh, a 5 goes into both of those. So I'm going to factor out a positive 5. And when I do that, it leaves me with a k. And when I did 20 divided by 5, I get 4. And all of a sudden, lo and behold, Ms. Lloreda did not lie. There's your matching binomials. You got a k plus 4 and a k plus 4. There's a factor in each one of those now. So I can factor that binomial, GCF, out to the front. And in the parentheses, just leave these guys that are left behind when I factor that out. So in the other parentheses, I just write the 7k plus the positive 5. And there it is, fully factored. That is factoring by grouping. This is how you're going to tackle anytime we have a polynomial with 4 terms. There you have it. Okay. Let's try number 4. I'm going to jump to that one. Okay. So this is a great example of a problem where looking for a GCF pays off. Those are pretty big numbers. Okay. And if I have to deal with bigger numbers, I really increase my possibility or probability of making some careless mistakes or computational errors. But if I notice they all end in a 5, so one easy quick fix to make life a little easier is I can tell these are all divisible by 5. There is a GCF of 5 here, so I can pull a 5 and make these numbers just that much smaller and more manageable. So when I divide 100 by 5, I get just 21 n to the third. There's not a variable GCF, unfortunately, but there was the 5 that I could do. So that comes out to 21 n to the third. When I do 175 divided by 5, I get 35 n squared. In the next term, when I do negative 75 divided by 5, it's negative 15 n. And last but not least, negative 125 divided by 5 is just 25. Negative 25. Okay? So that made the numbers at least a little smaller. So what I want you to realize is that GCF, that 5, is part of your answer, and a lot of times people forget it. So what I'm going to do is I'm going to just make a little arrow and say, hey, I'm not going to forget that that was part of one of the factors. So I'm going to have it in my answer ready to go. So as long as I don't forget to put it in my answer, I don't have to worry about the 5 anymore. I'm now going to focus on factoring this 4-term polynomial by grouping. So I'm going to group each one of those and play the game. And again, I'm going to go a little faster. 21 and 35 have a 7 in common, and n to the third and n squared have n squared in common. That's my lowest power, so that's my GCF. So 7n squared is what I can factor here. That leaves me with 3n plus 5. Okay, because 21 divided by 7 is 3. 35 by 7 is 5, and I still have an n in the first term there. Okay, so that's the first one. Let's practice this one right here. So I have a negative 15 and a negative 25 here, or negative 15n. So I noticed that certainly I can pull a 5, but I don't want to just pull out a regular 5. These are both negative. Remember, our goal is for the parentheses to match. If I only pull out a 5 here, negative 15 divided by 5 is going to end up giving me a negative 3n, and a negative 25 divided by 5 is going to give me a negative 5. That does not match. I need them to match. But that's an easy fix. Instead of just dividing by positive 5 and leaving the negatives in, what I can do is say, oh, let's make our GCF a negative 5. And then when I divide negative 15 by a negative 5, I get the positive 3 that I want to make my match. And when I do negative 25 divided by negative 5, I get a positive 5 to get my match. And now it works. So notice your sign. Sometimes you have to make sure that GCF you pull it as a negative, so you do get that match that you needed. Okay? All right. And so now we can finish this out and say, all right, well, now we have that matching 3n plus 5. So that's one of our factors. And the other one will be the GCFs, which are the 7n squared minus the 5, and then just don't forget that 5 that we had pulled at the very beginning, otherwise your answer is totally wrong. Boom. Okay, and that's the fully factored version. You can look at each one of those specific terms. None of them can be factored further. There's no GCF. There's nothing else you can do. And if you multiplied all that together, you would go back to the original. So we know we did it right. Okay, so you just learned a pretty important skill, which is factoring by grouping, which is how we factor 4 terms. Now, my lesson started talking about trinomials, not 4-term polynomials, right? So yes, you learned that skill too. But one of the main places we use this is actually for these more complex trinomials where that leading coefficient is not 1. Okay? And the process that we're going to be doing is truly going to be unfoiling, because the method I showed you was for how many terms? 4 terms. Remember how many products we end up originally when we FOIL? Oh yeah, FOIL is our favorite 4-letter F word, right? So it has 4 products, even though at the end we combine 2 of them together. So we're going to unfoil this using this particular, magic number trick that we learned. And then when we unfoil it and we have the original first, outer, inner, last, we'll just factor by grouping. So that's our name of the game. Now, again, that A value is going to change up the game. So please pay attention. This is a nice little step-by-step guide, okay? But there's a few things that are different about this magic number trick than the one that you learned the first time. When you have a number in front of your x squared, or basically a leading coefficient, instead of just looking for, what are 2 factors of 6 that add up to 17, right? That's what we were doing just a day or two ago, right? Because pretty quickly you're going to realize nothing that multiplies to 6 will add up to 17. That's too big. That's because you're ignoring the 5. So what's different here is that when you have a number in your leading term, you have to take that A value, what we call A. This is called A squared plus B squared C squared. AX squared plus BX plus C. That first term and that constant, we have to multiply them together. Okay, so if I have a number in front of the x squared, we're going to multiply that first, and then we'll use that product in the magic number trick. Okay, so instead of just saying what are 2 factors of 6 that add up to 17, I'm going to do 5 times 6 first, and then I'm going to play the game. I'm going to say what are 2 factors of 30 that add up to 17. And when I find those 2 magic numbers, right, 2 and 15, what I'm going to do is I'm going to take that 17x that was in the middle, and I'm going to break it up. Because remember how we always used to combine the middle terms? We're uncombining that middle term. So we're going to take those 17x's that got combined, and we're going to uncombine them back to the 2x and the 15x. We're going to separate them back out. Guess what? That was that outer and that inner product before they got combined together. That's why I like to call this unfoiling. Literally the reverse of FOIL, right? So we're breaking up those 2. Notice they're still like terms. I mean, we could still take 15x plus 2x and get 17x. It's equivalent. But we're splitting it up into the 2 correct numbers that must have been the products when we were doing first, outer, inner, last. Once you rewrite it like this, then it's just factor by grouping, which is what you learned a moment ago. You group, you find a GCF, and you factor by grouping. So let's play this game. Let's try it out. Okay? Take a look at number 5. Okay? So it's a trinomial. And yesterday, if that 12 hadn't been there, we would jump right to the -2 and say, oh, what are 2 factors of -2 that add up to 5? But now we have the 12 there. So before we begin that magic numbers, we got to take these 2 and multiply them together and use that. So 12 times -2 is a -24. That's the number I need to use in my little magic number game. Okay? So I'm asking myself, what are 2 factors of -24 that combine to 5, a sum or difference, right? So in fact, it's negative, so I know they have to be subtracting to 5. So I got to think for a moment for factors of 24 that combine to 5, and hopefully after a bit you realize, oh, it's got to be a -3 and a +8. Those multiply to give us a -24, but then they combine together to give us a 5. So that reveals, that helps us find our two middle terms that we're about to split this up to. All right, so that's what I'm going to use. Please notice that the 24, we used it to find this, but we don't need it anymore. Please don't try to kind of bring it into your polynomial. It's not part of the polynomial. Just, we're done with that 24. So now we're going to just take this guy right here, this original one, and we are going to just rewrite it. Just copy it again. Okay, 12a squared, except instead of writing those 5a's all together, we're going to split them up into the two magic numbers. So instead of writing 5a in the middle, okay, we're going to write negative 3a plus 8a. And then we'll still write the negative 2. But all I've done is split that middle term up into those two magic numbers. It's still equivalent to the original, guys. Negative 3a plus 8a is still 5a. But I've uncombined that O and I, that inner-outer product. I've uncombined them. This is what the first, outer, inner, last products were before they combined the middle terms. Okay, this is what they were originally. So I split it up. And now I have 1, 2, 3, 4 terms. So now we just factor by grouping. We group the first two. We group the last two. We look for a GCF in the first group, which is a 3a. And we divide it out, which will leave me with a 4a minus 1. Because 3a divided by 3a is 1. In the second group, I'll look for a GCF. And I'll notice that they share a common factor of 2. When I divide the factor of 2 out, 8a divided by 2 is 4a. Negative 2 divided by 2 is negative 1. And then we'll notice they have that common binomial factor, the 4a minus 1. They both contain that. So we'll factor that out. 4a minus 1 is one of our factors in the end, and the 3a and the positive 2 become the other parentheses. Okay? And that right there is the correct binomial factors, the factored version. It's fully factored, and if we were to FOIL it back, we would get back to the original. Okay? That's how you factor trinomials that have a leading coefficient. Let's try number 6. So on number 6, again, if I see a number right here, I know I have to use this particular method. So before we begin our magic number trick, we'll first multiply the 6 times the 4. That'll give us a 24. That's what I'll use to play my little magic number game. So I'm looking for two factors of 24 that when combined give me a negative 11. Well, if I just did number 5, I might catch this pretty quickly. It's going to be this time a negative 3 and a negative 8. So the same digits, but both of them are negative. That would produce a positive 24 like they want, but then combined to a negative 11. And as soon as I find those two magic numbers, I'm now going to just rewrite the polynomial we started with, but I'm going to split up the middle term. So I'm going to start with that 6k squared. That doesn't change, excuse me. But the 11k's, instead of the negative 11k's, instead of being written nice and together like that, I'm going to split them up into the negative 3k and the negative 8k. And by the way, if you're wondering which one do I have to write first, here's the awesome news. It doesn't matter. I could have put the 8 first or the 3. It actually ends up working exactly the same. It's amazing. Math is just, it's endless in its awesomeness. Okay, so we split it up. I put the negative 3 in front and then the negative 8, but it doesn't really matter as long as they're both with a k there. Everything else should stay the same. Please make a note of that, right? The 6k squared is still there. The 4 is there. If I combine those, I still have negative 11k. I really haven't changed this polynomial's values, right? I've just written them differently with 4 terms instead of just 3. And that lets me use the factoring by grouping. Let's do it. I'll group the first two and I'll group the last two. So in this first one, I have a GCF of 3k, and that will leave me with 2k minus 1. In the second group, I have a GCF of 4, but here's where, these are the kind of places where you got to be careful. If I only pull a 4 out, I would end up with a negative 2k and plus 1. And that would actually be the opposite of what I want. But that's a pretty easy fix. I showed you all that earlier. Instead of pulling just a 4, what I can do here is pull a negative 4. Knowing that when I divide out that negative, it's going to change my signs and get them to match like I need them to. So I'll pull a -4, and then -8 divided by -4 does give me a positive k like I want. And then +4 divided by -4 is a -1 like I want. And now I have a perfect match. And those are my factors. So I've got a 2k minus 1 is one of our factors here. And then the 3k and the -4 come together. The two GCFs you pulled as the other factor. And again, you could test this out and FOIL it, and you'll see you'll get the original. It works beautifully. And that is fully factored. So I'm going to say put a pause on this and try, actually, I would say let's try number 8. Number 7, feel free to try it. It's got some pretty big numbers. You're welcome to give it a shot. The numbers are a little big. So if you're just getting started, maybe try number 8 first. Pause your video, and then you can check your answer. All right, so I'm going straight to number 8, and when we do 15 times the -8, remember you have to do that first if the leading coefficient is not 1. 15 times -8 is -120, so we're looking for two factors of -120 that add up to 14, or actually subtract to 14 because it's a negative. My apologies. So after a little bit of search, this one might take a little bit extra time, right? It's a bigger number, but it still works. And tomorrow when you're in class, I'm going to show you a nice way to check that, to find those numbers on the calculator when you're really stuck. Okay? So that's why I'm going to leave number 7 for when we see each other in class. But I realized, oh, -6 and 20. When I multiply -6 times 20, I do get a -120. But when I combine those, I get a +14. Bingo! These are our two numbers right here. Okay? So then we'll recopy 15 squared. And all I'm going to change is, instead of writing that 14b all nice and clean, I'm going to separate it out into a -6b and a +20b. And then the -8 is still there. The other two terms do not change. I'm not really wanting to change my polynomial. I'm just splitting up the middle term. Okay? And then we group, and factor by grouping. Okay? So in the first term, our GCF, or in the first group, I should say, our GCF is a 3 and a b. That leaves us with a 5b minus 2. In the second group, I want to acknowledge there's a 4 in there that I can factor out, a +4 in fact, and that leaves me with a, oh, look at that, 5b minus 4. Oh, sorry, minus. All right, and then we have our matching little binomial. So 5b is one of our factors, and in the other parentheses is the other GCF, the 3b plus 4. They go together, and those are your factors. So hopefully you're catching on to kind of the idea here. I would say let's try one more together, and if you feel good, then the rest of those can be practiced. In fact, I'm going to jump down to some that have multiple variables, so you have one done for you. So I'm going to skip through these guys, although they're essentially the same idea. You can check them out, and we're going to probably do one or two of those in class. I'm going to jump over here to the multiple variables. So if you notice, 13 and 14, they have two different variables. And I want you to understand that that really doesn't change your steps in any way. You'll see that if you just follow the recipe, you'll still be able to bake this cake. Okay? So let's get started. If we have an 18 in here in front, we'll multiply these guys first. 18 times 2 is negative 36. We will find two magic numbers that multiply to negative 36, but combine to a negative 9. They have to have a difference of 9, but I think 3 and 12 here. So probably 12 and 3, and the 12 would have to be the negative 1 for those to work. Yeah, that works. Perfect. Okay, so those are my magic numbers. So now I'll take my original and rewrite it, splitting the middle term. So I'll get 18 m squared, and then I'll take the middle term and split it up into 12m times n plus 3m times n, and then minus the 2m room. That just split the middle term there into the two magic numbers, and then we can group the first two, group the last two, and look for a GCF. So 18 and 12 have a common factor of 6, and both of those have at least one m to give me there. The n doesn't work, and I can't do two m's, but I can definitely pull one factor of m, and that's the most I can do. So let's do it. 18 divided by 6 is 3, and if I had m squared and I divided 1 out, I'd still have 1. in the second term. Negative 12 divided by 6 is negative 2. The m is gone because I factored it, but I still have an n. There it is. Now let's do the second group. 3mn minus 2n squared do not have a numeric GCF, but they do have an n in common. So if I factor out an n, I need to pick other ones next time that aren't as hard to say. Okay, if I pull out an m, that leaves me with 3m. I'm trying to be very, emphasize my letters here. And then in the second term, I would have the negative 2 still, and then 1n left because I only factored 1 out. And if I did that all correctly, we still get that match. Even though there's different variables here, we still get that matching, binomial here and here. So that's one of our factors. And the other, of course, is the GCFs we pulled, the 6m plus the n. And it still worked. I did really nothing different at all. Okay? It was exactly the same steps. So don't let the two different variable situation kind of, intimidate you. It's got a lot more bark than bite. Okay? So, things that we're going to do, just put a pin on this. When we come back together, I definitely want to talk about negative signs. So we're going to back it up a little bit and for sure work number 10 together tomorrow in class. And then I do want to practice one more with different variables. So we're definitely going to do number 14. So 10 and 14, expect to do those in class together. And then if you want to see any additional ones, I'm always happy to help.